Well, hello. My name is Mr. Lisey. For those of you who have not yet met me, it's a pleasure to have you in class. Thanks for tuning in, and I hope this quarter is going to be a good one for you. We're going to try to get you to do as many lab type things as possible when you're in school and try to have you as hands-on as possible when you're out of school as well. So we'll try to find a little bit of balance between either of these. Regardless, if you do have any questions at any point, guys, please don't hesitate to ship me an email and I'll make sure that I get back to you. I'd love to communicate with you and just try to clear up anything that might be a little bit confusing. So what we're going to talk about today for science, the root word of science actually comes from a Greek word which means to know. If we want to know more about the world, which is what we do when we study science, we're going to have to study it in a certain way. And one of these ways is simply by using the aspects of observation and inference. We're going to be using these terms when we study and explore the world around us. And so we have to figure out what those words mean a little bit and how they help us in science. So think about it this way. If you visit the doctor, you go to the doctor's office, what things are they going to do when you get there? What types of observations is he or she going to make? Okay, so just kind of think about for a second, if you've gone to the doctor, what types of things are they going to do? Well, they're going to probably take your temperature, they're going to measure your height, your weight, they're going to maybe take your blood pressure, maybe look in your eyes, maybe look in your ears, maybe have you stick out your tongue, maybe tap your knee. There's going to be all sorts of observations they're going to make. Okay, the more different types of observations they make, the more likely they are to draw the correct inference about what might be wrong with you. So we make observations in order to get a more accurate portrayal of the world around us. Okay, so kind of think of yourself as being kind of like the doctor in your situation. A scientist is going to operate the same way. They're going to try to make observations in order to figure out the world around them. Okay, so science works through making observations, and there's different types of observations. Okay, they can either be qualitative observations or they can be quantitative observations. So the difference is that quantitative is going to involve measurements or numbers, and it's going to end up being probably a little bit more precise than a qualitative observation. So you might observe that 7th graders are short. Okay, that'd be a qualitative observation. Doesn't measure it all, just says that they're short. A quantitative measurement would say that the average height of a 7th grader is 74 centimeters. A qualitative observation might be that teachers are old. You might add some other adjectives to that as well, which might not be so nice. But that's a qualitative observation. Or you could say that the oldest teacher at Red Wing is 56 years old. That is a quantitative observation. And you could say the school year is too long. And in this case, you could say, well, Red Wing students have 174 class days. Actually, this year it's 170. So this is more of kind of like an opinion, but it's just an observation that you're making. But these are observations that we are going to use to help us understand the world around us. But oftentimes, especially this year, we are going to be doing lots of measurements. And what measurements are going to do is they're going to help provide quantitative observations. They involve quantities. So that's the difference between the two. So what we're going to do right now is I'm going to do a little demonstration involving a substance called lycopodium powder. And it's a fancy schmancy name for something that looks like this on the screen right here. Okay, it's this yellowish powder, nothing, kind of nondescript. But what lycopodium powder is really kind of a fancy schmancy way of just saying it's basically the pollen from pine trees. Okay, and so this is the plant that this substance comes from. So I'm going to do a little demonstration related to this, and I'm going to have you make a couple observations about that. Let me pause the video here for a second, and we will try to figure things out with that a little bit. And I'm going to do a little bit of this right here is lycopodium powder. Okay, it's this yellowish substance, just the pollen from pine trees. And I'm going to take my lighter, and I'm going to try to light this lycopodium powder. And it lights up a little bit, but it doesn't really want to get started too much here. Okay, a little bit around the edges. Let's change things up a little bit. Okay, let me pause this again. So now you see I've got a Bunsen burner lit right here. and I've got the same lycopodium powder right here, but I'm going to do something a little bit different this time. And what I'm going to do is I'm going to invert this powder over this Bunsen burner flame here. And I've got my goggles on. I'm trying to be safe. Okay. So watch what happens when I do this. Again, you're making an observation. You're going to try to draw an inference from it. So, obviously, a big difference between the two situations. Okay? There's a big difference in what happened that time. There, basically, all of it ignited. So, what type of inferences would you draw from that situation? Why did it act differently in the second situation? So kind of think about it and see whether or not you can draw the right conclusion from that. Why would it all burn in the second situation and not all combust in the first situation? Now, if your answer happened to be that when it was all spread apart, that it had more surface area that could be exposed to oxygen and that's why it combusted more, you'd be completely accurate. Okay, that was a correct inference based upon the two sets of observations I gave you. Okay, so that's going to be our plan for today. We're going to kind of look at that situation and we're going to try to analyze what's happening. So I'm going to have you guys try a situation here where I'm going to have you guys open an attachment that is going to be connected to your Google Classroom. And let me just kind of change things around here a little bit. And this is what you're going to be looking at. Okay, you're going to be looking at this. It's called a frog study. And what they found out is that in some lakes and ponds, they found out that some frogs were deformed. Okay, some had extra legs, some had missing legs, and obviously not a good thing for the frogs and probably not a good thing for the environment if that's happening. So what you're going to do is you're going to have these observations, and then you're going to study some various possible causes for why those frog deformities are happening. And you're going to run through those. You're going to study each of these and figure out what might be causing each of these and what types of things we might be seeing with these. And your job, when you go through each of these links here and study it, is going to be to try to figure out the exact cause. You're kind of like a detective on this case. You're going to try to find the cause of why these frogs are deformed. And as you go through this, I want you to just kind of take notes as you go along. And I want you to open up another tab. This is also on your Google Classroom. And I want you to work through, this is the website, and I want you to think about what hypothesis is going to be the most valid, which one works best to explain those frog deformations, and then explain why you eliminated some of those other possible hypotheses. You've made observations that the frog's legs are deformed. You're going to draw inferences about why it happened. And I want you to work through this website and come up with these answers and finish it by the end of the hour. Make sure it's submitted by tomorrow for grading. And we are going to probably discuss it in a class or two. If you have any questions related to this, please do not hesitate to send me an email